It didn't beep. Oh, because the speakers are off. As always, when we open with a new unit, there's a bunch of vocabulary. I'm going to be using that vocabulary throughout the whole unit, so please make sure you learn what these words mean. And of course, I am going to highlight those important words. Set, element, and relation. Okay? So, let us begin with a set. Do you guys know what a set is? You should. You made Venn diagrams in grade 5 with Mrs. Bad Crumble. What is a set? Pardon? A pair of something could be a set. It's a good example of it. Good. Okay, well, we're starting from the real basics then, aren't we? A set is a collection of anything you can count. Now, in math and science, we call anything you can count is data. Everything you can count is data. Okay? Everybody cool? Data. Some people say data if they're American, but the real word is data because, of course, it is an A and an A, and there are no E's there to make either of those vowels long. So it is data. No, it's all right. A great many of you also call the last letter of the alphabet Z.
I say both of them.
You like saying Z because it rhymes better. Yes. We are not all hip-hop artists. We do not need to rhyme. As a matter of fact, almost no time do we need to rhyme. All right. So, let's do an example of that. Here is an example that applies to you guys right now. A set could be kids in this room. Now, is that the total set of people in this room? Why not? Because I'm not a kid. Mental age does not count. Everybody understand? So if I call that a set, then how many sets are there in this room? No. A set is a whole collection. So how many sets are in this room if I call this one set? There's 2 sets in this room. One of those sets is all of you. And what's the other set? Me. Got it? Everybody with me? Okay. So the next thing is an element. What do you think an element is? Yes, absolutely right. An element is any single item from a given set. So, keeping with my red example here, what would be an example of an element in this room, in this set? Yes, yes. So the example here is any one of you guys. Now, if I change color and I add the second set to this room, adults, how many elements are in that second set? Say it out loud, Mark. 1. Who is that element? Me. Is everybody with me on that? Even though the set that includes me only has one element, it is still a set because you can count one of me. Understand? Now, If Mr. DeVries were to walk in, does that change the red set? No. Does it change the green set? Yes. Does it change a third set, which I will write in gray, that is people? Would it change that set? Yes. Is everybody with me? Cool? Okay. Now, you guys are smart kids. In reality, a relation, you know what a relation is. Your brother, your sister, your cousin, right? We're cool with that, yeah? Okay. In math, a relation is any association of elements from one set to another set. Okay? So if you can relate them, that means they're the same in two different sets. Okay? Now, let's do an example of that. Keeping with the red, because that's kids in this room. How could we illustrate a relationship with another set? What could I do to physically show you that relationship? You guys are all kids in a classroom, yes? Could you be related to another set in this building? Girls and boys would be two different sets. But you could also relate them. But we'll come back to that in a second. Keep that in your head. Put a pin in it, Caitlin, because I'm going to talk about it in a minute. If I told you to go get a partner from everybody in Keeley's class right now, would that be a relation? Why? Because they're another set. And if I told you to walk over and grab one of them, that is a relation, yes? Because you, Cassie, are one element of this set. You are going over and grabbing an element of another set. Okay? Be pleasant about it. They might not like it. Don't give them one of these. Do you understand what I am saying? Now, Caitlin's example was boys and girls. Could I split... Oh, well, let's get our example here. Grab a partner from Keeley's class. Okay, cool? Now, Caitlin said, well, what if it was boys and girls? Could we do that? If I split this red set into two other sets, the obvious set that you used back in grade 3 is boys and girls, yes? Right? In this room, there are 2, 4, 6, 8, 10, 12, 14, 16 girls. And if everybody was here, there would be 14 boys, because there's 30 kids in the class, right? Can I relate the two? I can. If every girl went and sat beside a boy, I'd have a relation, but there'd be leftovers, wouldn't there? 2 girls would be left over. So is that a one-to-one relation? No. So 2 of those girls would have to sit with 1 boy, right? Right? So 2 of those boys would have 2 girls with them. Does everybody understand that? You need to keep that in your head because it's about to be explained why that's important in a second. Okay? All right, so let's go to the next one. There is a graph, right? Graphs need 4 things in math or physics. All graphs have to have these 4 things. Okay? The first thing a graph needs is a title. If you don't have a title, I don't know what I'm looking at. Okay? That's the first thing every graph needs. All right? The second thing every graph needs are scales. Scales are how we are measuring. Not how we are measuring. So how are we measuring here? What do you think that is? I just put a bunch of numbers, right? So what must that be? What's missing from this? That, yeah, it needs a unit. This is not scaled, is it? What am I counting there? Right? We got to say it. All right? And at the bottom here, we're not counting numbers. We're counting different dog types. But it's still labeled. Cool? The third thing you need, we've got our scales. We need labels. So this side, does this side have a label yet? No. What are we labeling here? So let's label it. We have height. That's our label. And in centimeters. That's our scale. Right? What about along the bottom here? What am I going to label it? Dog, breed, or type, whatever. Can I put a scale down there? No, I don't need a scale there because that's not something we're counting, yeah? All right, everybody cool with that? Yes? Everyone is good? Okay. And the third thing it needs, or the fourth thing it needs is our data. And data can be presented in many ways. You guys have done this to death. You can make a bar graph, you can make a line graph, you can make a pie graph, you can make a blah, 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 blah. Everybody's made graphs. You've all been in socials and science before. Not going to spend any time on that. It just needs the data. That's the fourth thing. Okay? Now, here's where we get a new word. A function. Okay? You guys should turn, do you need to turn your page over? Yep. A function. So, do I want to do that yet? No, I don't want to do that yet. I don't want to do a function yet. I want you, go back a page. I'm sorry, I'm a dink. It's my fault, not yours. Go back a page. You got a bunch of blank space at the bottom, right? There's something I want to put there that I don't think I have further in your notes. It was a mistake when I printed this the first time. So you got to put it in there. We'll come back to this function thing in a minute. The first thing I want to put down here is what is called set notation. And we're going to highlight that. Set notation means we use these funky brackets, the devil horn brackets from the emoji. Those ones. Okay? A lot of people can't draw them. I don't care how you draw them. Just draw them squiggly. It doesn't matter. This is an art class. Okay? Those arrows mean the set of. But math guys are lazy. They don't like to write it. Okay? Everybody cool? Now, on this graph, knowing everything you know about sets and elements and things, how many sets are there on this graph? Antonio says there is one. We're used to listening to Antonio because he is 99.9% of the time right. There's two sets here, aren't there? Because there's two things being counted. What are the two things being counted? Look at the graph. What are the two things that are being counted? The height and the type of dog, yes? So, there's two sets. One set is the dog type. Hound, right? Chihuahua. I'm not going to write Chihuahua because I'm lazy and they're not real animals. They don't deserve the whole title. They're not. They're not. I have hamsters that could have destroyed a Chihuahua. To each their own is what I say to people who own Chihuahuas. You have a Chihuahua too? You're from Germany. One of the most noble dogs in the world is German. And you have a Chihuahua? Do you have a German Shepherd? Or an Alsatian, if you wish to call him that? No, yet you have a Chihuahua.
Just because a friend of my sister needed somebody to take care of it.
And then she realized, hey, those suckers are going to take him, and I don't have to have that yappy little piece of crap back. Yes, exactly. If you love your Chihuahua, you're more than allowed to love your Chihuahua. I just don't understand it. Much like many of you probably spend time wondering why my wife has been with me for 20 years. I get it. Looks can only take you so far. All right. What's the next one? Corgi. Corgis are a funny dog. If you don't know what a Corgi is, they're the type of dog the Queen of England has. They have a nice normal body and little tiny legs. Not like a Dachshund with the long wiener body. Regular body, but little tiny legs. They look like an accident. Like Corgis are an interesting animal. And then next, the best dogs, Labs and Shepherds. Lab, Shepherd. And finally, a Malamute, which is a wonderful dog if you live in a mansion with a giant backyard, because Malamutes are the size of small horses. And they're hairy. Yes, Malamutes are gigantic. Now,
What's a corgi? Oh, just like that.
regular size body, little bitty tiny legs. Not like a Dachshund body with the long wiener dog thing. Regular body with little tiny legs. My best friend growing up when we were in... Oh, there you go. I know. But the Queen loves them. So, whatever. When I was growing up, my friend had the truest, greatest dog in the world. Some of you may have heard this story. My friend had a crossbreed. As you all well know, purebred dogs, if there's a problem with their genetics and you purebreed, the problem becomes more and more and more so, which is why so many royal families have hemophilia, because royal people could only have babies with other royal people, and that's a small gene pool. Dogs are the same way. So crossbreeding dogs is a good way to keep them healthy. My friend's dog had a Chihuahua father and a Labrador mother. Now, many of you have been through biology. You're aware of how mammals do their business. You're also aware that a Labrador is yay big and a Chihuahua is yay big. It was not natural. The breeder thought, hey, let's see what happens if I take a Chihuahua and a Lab. And I mix them up and create a puppy. Very luckily, he ended up with a Labrador body, Chihuahua sized. So it was all bulky and big like a Labrador should be, but it was the size of a Chihuahua. I know. And everybody does that. Awesome. Until I say this. What if it had gone the other way? A Labrador-sized Chihuahua. And now all of us have a little bit of throw up in the back of their throat because they are picturing one of those little rat fiend dogs this big jumping up on you like the little vampires that they are. Anyways, okay, now there's a second set of heights, right? Everybody cool? Now, the elements of the height relate to the types of dogs, don't they? Because the hound has a height. How tall is the hound? 60. So that, ladies and gentlemen, is a relation. Cool? Because as soon as I say a hound, you know that it's 60 centimeters tall. If I say, hey, what dog is 60 centimeters? You know that it's the hound, yes? Cool? All right, so what's Chihuahua? 12. What's Corgi? 30. What's Lab? 45. What's Shepherd? 45. And what's Malamute? 80. Now, look closely. You already know I have a relation, don't I? Because this set relates to this set. Because every dog has a height. Cool? Everybody understand why this is a relationship? Dogs have heights. So every dog, you can find its height from the graph. And every height, you can find a dog. Yes? Now there is a problem with this relation. What is it? I have a 30 centimeter tall dog. What kind of dog is it? It's a Corgi. Right? My dog's a Malamute. How tall is it? 80. Excellent. I have a 45 centimeter tall dog. What dog is it? Lab or Shepherd. Right? Everybody with me? Keep that in your head when you go to the next box on the next page. Now turn your page. Pardon? Oh, yeah. No, I know. Yeah. That's not important, though. A function. Now, here's a very important distinction. A function is a specific. Please highlight, underline, do something. A specific type of relation. All right? Everybody ready for this? It is a specific type of relation whereby, which is a fun word to say in English, whereby one element in any set relates to only one element in the other set. Does everybody understand what I mean? Remember that example we had where we split the class into boys and girls? There's a relationship there, right? If I tell you to go sit beside a member of the opposite sex, you can all do that, yes? Except two girls, correct? What would happen to those two girls? They either could not sit beside somebody, or, for example, Caitlin would have to sit with Antonio, and then Sammy would sit with Antonio, and then Annalise would sit with Zach, and then Cassie would sit with Zach. Now, is that a function? A function means one element relates to only one element. It's not a function, is there? Because Zach is sitting with two girls. Right? So I would say to you guys, I would turn my back like this and I could say, Zach. And you wouldn't know to which girl I was speaking. Understand? Whereas if Faith was sitting with Mark and I said, Mark, it would be Faith. End of discussion. Function. With me? But because two of you are sitting with Zach, that's a relation, not a function. Everybody understand that? Okay? Now, obviously that has a place in math, but the concept is illustrated using English. Okay? So let's do that for the next couple of examples that I have there. Each month of the year relates with a certain number of days. Is it a function? Yes or no? Okay, so the first thing I say to myself, what are the two sets? What are the two things that I am counting here? Months is set 1. And set 2 is what? Number of days. Now, are they a relation? Does every month have a number of days? Yes. So it is a relation. Now we have to check if it's a function. January is the first month. How many days does it have? 31. Cool? That's a function right now, isn't it? There's one thing in the first set. It relates to one thing in the second set. Everybody cool? Function. Yes? Okay. What's the next month? February. How many days February have? Depends, doesn't it? 28 or 29. Is that a function or a relation now? It's a relation. Why? Because February relates to two different options. Everybody cool? March, 31, right? So, now I'll ask you this. If it's not a leap year, do we have a function now? "31" is repeated twice. If I say, I'm thinking of a month with 31 days, can you tell me what month I am thinking of? Could be January, March, May, July, August, December, October, right? So that is not a function. Is everybody with me? Okay? If I tell you the month, you can tell me the days. Cool? But if I tell you the days, you cannot tell me the month. Unless it's February. But even no, you can't. Because doesn't every month have 28 days? Or 29 days? Okay, is everybody with me? So this is a relation. Why is it a relation? Because the days repeat. Everybody cool? All right, let's look at the next one. Every name on my class list relates to an actual person in the room. Everybody cool with that? So what are the two sets? Set 1 is what? Names. And set 2 is what? What? Humans. People. Is this a function? Is it a relation? What do you mean it depends on the class, Antonio? If it has two people that have the same name, it's not a function anymore, is it? What are the chances they're going to have the same name? Because it would need to be first and last name, wouldn't it? That's something you got to think about, right? If I go by first name, is it most likely going to be a function or a relation? It could be a function, but there's a darn good chance it's going to be a relation, isn't it? Now, in this class, this is one of the very rare times that there is nobody in the class with the same first name. You all have your own first name, yes? So in our class, if we go by first name, it's a function, right? Why? No repeated first names. What if I go by last name? Is that a relation or a function? You guys would have to know everybody's last names. But think about your school. There's some groups of names, aren't there? You have a last name, twin. Absolutely you do. In this room we do too. We got two Verks, right? So this, in our class, is a relation. Why? Because we have a repeated last name. So if I do this, Charmaine looks at me because there is one kid in this room named Charmaine, right? Oh, there's two Zachs. You're right. Damn. Fudge sickle. Relation. Relation. Zach. Repeated last name, Burke. Now, what if I use both? Relation or function? That's a function. Why? Because if I say Antonio Stalker, that's only him. Right? He knows I am speaking to him. Right? Get a third name in there. Throw in a Lorenzo. Okay? Everybody with me? Now, sometimes this even happens. I have taught classes with two Jazreet Dylans. Right? That happens. What? Oh, yeah. Yeah, you're right. You're absolutely right. Verbally, that's not a set, is it? But written out, it would be. Good call. Okay? If I were to write on the board, Mark, see me after school, with a C, he knows it's him. With a K, that kid knows it's him. Everybody good? Everybody good with relation function? Okay. Okay. Dependent variable and independent variable. If you were in my class in 9th grade, you talked about these to death. You know the difference. Some of you won't. So, first thing we're going to talk about, all of these are important. And I'm going to highlight in colors the relation. Dependent variable relates to range, and independent variable relates to domain. Okay, we're going to talk about what they both mean in a minute. Dependent variable. First thing, abbreviate with a DV. What does dependent mean? Yeah, what does that mean? That's what he just said. Relying. Okay, what else? You need it, right? We are dependent on our food supply. Everybody cool? If there is no food, are there people? No. Everybody with me? If there is food, does there have to be people? No. Does everybody understand that? There could be a planet growing with all kinds of plants and animals running around on it, but nothing that resembles people. Right? But if there is something that resembles people, they have to have something to eat. Everybody cool? Everyone agrees? Okay. So a dependent variable is, now there's two words there. There's dependent and there's variable. So let's talk about dependent first. A dependent variable is any variable whose value is determined by another variable. Everybody okay with that? Now, the problem with this definition is I wanted a definition of dependent variable, didn't I? I defined dependent, but I didn't define variable, did I? And what did your English teacher teach you in like grade 4 when you were doing definitions? You're not allowed to use the word that you're defining in the definition, are you? So we got to define variable. What's a variable? Don't say X. Don't say Y. You're getting warmer. Unknown is what we need there. A variable is anything we can count that is usually and unknown at the beginning. Okay? So let me give you an example. I'm thinking of a month. Is that month for you people a variable or is it a constant? It's a variable. Why? Because you don't know what month I'm thinking of, yes? I'm thinking of a month that begins with M. Is it still a variable? Still a variable, right? I'm thinking of a month that begins with M and has 3 letters. So now, it's now no longer an unknown, but it was a variable until then, yes? Okay, now that you know I am thinking of May, how many days are in May? 31. So is that 31 a dependent or an independent variable? It depends on what month I am thinking of, yes? Everybody with me? So that leads us right into our discussion of what an independent variable is. Okay? An independent variable is an IV, and it is obviously any variable that stands alone.
Good morning. Here's your announcements.
Everybody cool?
November 28th.
We're stopping there. We're going to finish these notes and do work on this tomorrow. Okay?